Hello everyone, my name is Miko Getchev. I lead developer relations for Angular at Google. Today I'll share with you how to host a modern Angular application with Google Cloud Platform. We can render a single-page application implemented in Angular or any other front-end framework in three different ways. Client-side rendering, where the browser receives an index.html file with reference scripts. Once the scripts load, they render the application. Pre-rendering, or static site generation, is where at build time we render an HTML file per route. Once the browser loads the HTML file for a route, it renders it and loads the reference JavaScript. The page becomes interactive once the browser executes all the JavaScript. Finally, there is server-side rendering, or SSR. SSR is very similar to pre-rendering, with the main difference being that rendering happens at request time by a rendering server. Something in common between static site generation, or pre-rendering, and client-side rendering is that in both cases, we only deal with static resources. On the other side, in SSR, we need a server to render the application and produce the application's HTML at request time. To demonstrate the different rendering strategies and approaches and explore optimal deployment, we'll use the Kitty Cinema application. Kitty Cinema is a catalog of cat movies. We can explore a list of movies with their names, genres, and ratings. When we select a movie, we can get further details about the synopsis, the cast, as well to explore similar recommended movies. For this application, we can use client-side rendering. The deployment could be pretty simple. First, we build the application and get its production assets. After that, we can upload the assets using the Firebase tooling. Finally, the application will land on Firebase hosting and be globally available via our CDN. Currently, we can achieve this in a few different ways. First, we can use the Firebase Node.js command line tools. We can install them by using npm globally, running npm i-g firebase. After that, we can go to the Angular CLI workspace directory and initialize a Firebase project. We can run Firebase init. After that, choose configure for Firebase hosting. Select the project you want to deploy, specify a public directory. In this case, the Angular CLI uses the output directory dist movies browser. After that, we're going to rewrite all the URLs to index.html to make sure that Angular provides client-side routing. We're going to disable the deployment with GitHub. We're not going to overwrite index.html at this point. Since we have already built the application, as the next step, just type Firebase deploy and allow the tooling to deploy the app. Once all the files are in Firebase hosting, click on the output URL to preview the app. An alternative approach is using Angular CLI. You can run ng-add Angular Fire to add Firebase integration to your project. Select that you would like to set up ng-deploy. Select an account you would want to use, and next, select or create a new project. After that, select or create a new site. And finally, just run ng-deploy. This command will build your project and upload the static assets to Firebase hosting. You can preview the result following the output URL. Let us track step by step the sequence of events when the user opens the application. Once they enter the URL, their browser will send a request to Firebase hosting and download the index.html. That is the page for the application. The browser will render the HTML and show a progress bar. Next, the browser will download all the reference JavaScript within index.html. Next, the browser will execute the JavaScript. Notice that at this point, the user still sees only a progress bar. Until the rendering completes, the page will not be too useful. At this step, Angular will take over and render the user interface, making the page useful and interactive. For 3 out of the 4 steps, the user only sees a progress bar. That's not the best user experience. Depending on the network connection speed, it may take tens of seconds for the application to show useful information. In this particular case, we don't need to make the application interactive immediately. This is a content website, which means that even if you only show the movie list, the page will be still useful. After that, we can load the associated JavaScript and add interactivity. Let's explore a more optimal deployment strategy for the Kitty Cinema application. This way, we're going to quickly serve a useful page for the user and later on make it interactive. We can select a suitable strategy by identifying the different types of content we can render and taking performance into consideration. Ideally, we would want to pre-render everything at build time so that we can deploy the resources to a CDN and deliver them from the closest location to the user possible. Often pages depend on dynamic data store or user session information. When we need to store personalized content on a page, it becomes infeasible to generate it at build time. We're going to consider two rendering strategies. First one is pre-rendering for pages that don't change too often. Serving them from a CDN will be cheap and really fast. We don't have to do any work at request time, and we can deliver them from the closest to the user geographical location available. For pages that need to show personalized content or depend on a very frequently changing data source, we can use server-side rendering. It's usually more technically complicated and expensive to serve such pages because at request time, we'll have to run the application server, render the app, and deliver the produced HTML to the user. For pre-rendered content, we can use Firebase hosting. This is content delivery network, allows us to serve the pre-rendered pages from a close to the user location. For server-side rendering, we'll use Cloud Functions. They provide an on-demand execution environment which allows us to handle individual requests, render our single-page application in Node.js, and serve it to the client. To pre-render and server-side render our application, we're going to use Angular Universal. Just run in the terminal ng-add ng-universal express engine, and Angular CLI will set everything up automatically for you. Earlier this year, Google Cloud announced Cloud Functions 2nd generation, powered by Cloud Run. This new version provides more powerful infrastructure and advanced control on scalability and performance. They offer longer processing times and larger upgraded instances with more memory and virtual CPUs. To deploy our application, we'll use Firebase SDK for Cloud Functions, which allows us to configure them through code. The Firebase SDK allows us to only run Node.js in the function, which fits our goals really well. In case you want to use other technologies, check out this quick starting guide for Cloud Functions in Google Cloud Console. Let us have a look at two different pages in the app and identify the optimal rendering strategy for each one of them. We have a generic page that shows the popular Kitty movies. We also have a page that shows users' favorites. The generic page could be a good candidate for pre-rendering if the popular movies don't change too often. If they do change often though, we'll have to regenerate the application and redeploy it very frequently. In such a case, we might be better off using server-side rendering for it. The page showing the user's favorite movies depends on the session ID, which means that we can't generate it at build time and we'll have to use server-side rendering. An approach where we use server-side rendering for some of the pages in the app and pre-rendering for others is called hybrid rendering. With hybrid rendering, we can deploy the static resources of the application, for example, JavaScript, images, pre-rendered pages, etc., to a CDN, for example, with Firebase hosting. The pages containing dynamic content we render in Cloud Functions with server-side rendering. Let us look into how to deploy an application to Firebase hosting that uses hybrid rendering. To set up hybrid rendering, we can make a few adjustments to firebase.json. In this file, we can specify a pre-deploy command to our function and its source. Here we can specify that we want to build the Angular Universal server before we deploy the function. Next, we can specify the hosting configuration. We'll set the public directory to dist movies browser. We'll use clean URLs to strip the .html suffixes and also set trailing slash to false. Notice that we also add the ** rewrite to the SSR function. For optimal results, make sure that you also review the best practices for caching. Now let us compare the original client-side rendering application with the latest deployment that uses hybrid rendering. On the left side, you can see the client-side rendered application. And on the right side, you can see the pre-rendered application. Both are delivered from a CDN, but the client-side rendered application needs to load JavaScript before it can show any content to the user. Notice how the pre-rendered app loads and rendered in half of the time needed for the client-side rendered alternative. Selecting the correct rendering strategy can have a significant impact on your application's performance. Alright, that's mostly what I had for you today. Before we end, however, I want to share one more thing you can do to further automate the process of deployment of hybrid applications using incremental static generation. We already mentioned in what cases we should use pre-rendering and when we should go with server-side rendering. In short, if a page is user-specific or changes very frequently, we most certainly want to use server-side rendering for it. We also discussed that we pre-render pages at build time. Let us look into incremental approach to pre-rendering. To achieve incremental pre-rendering or static site generation, we can use automation via the APIs that Firestore offers. Let's suppose that we store all the content that our static pages depend on in Firestore. When we update the Firestore data, we can get a Firestore change event that triggers the incremental static regeneration. Once we regenerate pages that changed, we can just deploy them to Firebase hosting. Deploying to Firebase hosting purges the cache content from the CDN. So we will want to balance deploying on every change versus regenerating static content periodically while still falling back to SSR. That's everything I had for you today. In this presentation, we had a look into different pre-rendering strategies for single-page applications and most optimal deployment techniques for each one of them. For more content, make sure you follow Angular on Twitter and subscribe to the Angular YouTube channel. See you next time and happy coding!